Okay, let's move on to work, power and energy. What is work done? The symbol is capital W. The process of displacing an object using unbalanced force. So this is the force, this is the angle, so this is F, alpha, displacement is S. So in order to find work done, capital W, what you have to do is take the component of force along the displacement. Into the displacement gives you the work done. So we can conclude the unit as joules, dimensions ml square t minus 2. When alpha equals 0, what happens? Cos 0 equals 1, which means W equals Fs, which means the force along the displacement. Let's consider alpha equals 90. What happens? Cos 90, that is 0, which means W equals 0. When the force is perpendicular with the displacement of the object, you can conclude the work done by the force is 0. For example, you can consider this object. This is the tension, this is the moving direction, that is 90, moving direction. So since the direction of force is perpendicular with the moving direction, W equals 0 here. W equals 0. In order to find kinetic energy of an object, you have to consider half mv square, which means when an object of mass simple m moves with simple v velocity, kinetic energy is half mv square. So what is the relationship between kinetic energy and momentum? So we know that E equals half mv square, and the other thing is momentum equals m into v. So we can subject v as p divided by m. So then E equals half into m into p square divided by m square, m getting cancelled off, we can conclude E equals p square divided by m. That is the relationship between kinetic energy and momentum. Kinetic energy and momentum. Okay, let's consider potential energy. What is potential energy? The energy gained by the object when it is in gravitational field. So in order to get the potential energy of an object, you may have to consider potential energy 0 level. Potential energy 0 level. So when an object of mass simple m at a height of simple h, you can consider the potential energy as plus mgh. While the object is at a depth of simple h, what happens? The potential energy minus mgh. For example, you are given that the flight the kinetic energy and the potential energy of the flight is equal to each other. So you may have to find the velocity of the flight. So what happens, you can take the potential energy as zero level, so the potential energy EP should be equal to kinetic energy. So potential energy, let's take the mass as simple m, and the kinetic energy half mv square. So if the potential energy and the kinetic energies are equal to each other, what happens? We can conclude the V equals root 2gh. That is our conclusion. That is the relationship between velocity and the height when potential energy and kinetic energies are equal to each other. Let's move on to force constant or spring constant. What is force constant or spring constant? The force need to be given on spring in order to compress or extend it by 1 meter. So that is called as force constant. So if the extension of the spring is x, the required force should be kx. F equals kx. And the other thing is the elastic potential energy is taken as half kx square. Let's consider the variation of force with the extension. So it should be a linear one. If the extension is x and the required force is F, the area on x-axis gives you the elastic potential energy. So how would you find E? That is half into base into height. So E equals half Fx, and since F equals Kx, what happens? E equals half Kx square. That is our conclusion. Let's move on to conservation of energy. What is principle of conservation of energy? So energy can't be created or destroyed. It can only be transferred from one energy to another. That is called principle of conservation of energy. Let's move on to take the relationship between work done and the energy gained by the object. So take the initial velocity of the object as u and the final velocity as v during a displacement as simple as. So we can conclude work done by the force is equal energy stored. Energy stored, the work done by the force, that is F into S. Energy stored means initially there was a kinetic energy and finally another kinetic energy. You have to take the difference of those two. The difference of kinetic energies gives you work done by the force. Work done by the force. So if this force is acting as friction, what happens? The velocity of the object decreases as the time progresses. So you have to consider the work done by the friction is equal to kinetic energy, loss in kinetic energy. The same equation, but the force should be opposite with the moving direction. Opposite with the moving direction. Let's move on to power. Power is known as the rate of work done. So in order to get the power, work done or energy should be divided by time. So joules, seconds, joules per second. So the unit should be watt. Unit should be watt. So the dimension ml square t minus 3. That is the dimension of power. Since W equals work done equals F into S, you can consider F into S divided by T. Since S divided by T equals V, what happens? P equals FV. P equals FV. But you are not allowed to use this equation when object moves with uniform acceleration. So you are only allowed to use when object moves with uniform velocity. So what is that force? That is called the accelerating force, which means the force required in order to maintain uniform velocity. Uniform velocity. So we can consider this instance, the vehicle moves with uniform velocity. There is a friction like simple F. This is called accelerating force. In order to maintain the velocity as V, the accelerating force should be equal to the friction. So P equals simple F into V, because capital F is equal to simple F, that is friction. But when considering this instant, that is quite a different case, which means here the vehicle moves with uniform velocity. There is a weight like mg. You may have to consider the component of weight along the inclined plane. So you know that mg sin alpha as well as the friction. So here what would be the accelerating force? So that is none other than the addition of these two. That is simple F plus mg sin alpha gives you the accelerating force. Therefore, power of the engine equals F into V. F equals simple F. Since the accelerating force has F plus mg sin alpha into V gives you the power. Let's move on to this example. Train of mass ME moves with its 7 carriages. You can take the mass of each as mc. So the mass is 7 mc. You are given the velocity. As 36 kilometers per hour, and the power of the engine is 60,000 watt. Power of the engine is 60,000 watt. For another instance, it carries 2 carriages only. So the speed is given as 54 kilometers per hour. Power is the same as 60 watt. And you may have to consider the friction is 0.1 per kilogram. 0.1 newtons per kilogram. So, how would you find the friction exerting on the system? So, you may have to consider the whole mass as 7 mc plus me, 7 mc plus me into, main important one is into 0.1 in order to find the friction, because friction is 0.1 newtons per kilogram. So in order to maintain the uniform velocity, the accelerating force should be equal to the friction. We know that. So the relationship between those 3 can be taken as P equals Fe. P is 60,000, F is 7 mc plus me into 0.1, and the velocity is 36. It should be multiplied by 5 upon 80. So this is 2, this becomes 10, 1, so 60,000 equals 7 mc plus me. So 2 unknowns, there should be 2 equations. What is the other? So when considering this case, same procedure can be followed. So 60,000 should be equal to 2 mc plus me. The friction, in order to find the friction, the total mass should be multiplied by 0.1. And again, the velocity 54, but it should be converted into meters per second by multiplying 5 upon 80. So this is 1.5. So what happens here? This is 3 mc plus 1.5 me. This is second equation. 2 unknowns, 2 equations. First of all, we can equal first and second as 7 mc plus me as 3 mc plus 1.5 me. So this is 0.5 me equals 4 mc, which means me equals 8 mc. Then you can consider the first equation. So what happens when considering first? 60,000 is equal to 7 instead of mc, or rather let's take me as 8 mc. So 7 mc plus, instead of me, 8 mc, total is 15 mc, 60,000. So mc becomes 4,000 kilograms, 4,000. So therefore me equals 8 8 times that of 400s, altogether 32,000 kilograms. That is the mass of engine. That's all.